Carbons group 4, see, 1, 2, 3, 4, but since these are available for bonding, the carbon itself, you want to be a little more organized, right? So you want to say 1, 2, 3, 4, like that, right? And you draw other carbons, you're going to do the same thing. 1, 2, 3, 4, right? And then you see you have C2H2. So you draw hydrogen on either side. Hydrogen only needs 2 electrons to be happy. Right? Violation of exception today. Now you draw your overlaps, right? When you draw your overlaps, you want to draw over the whole thing. So you say 2, 4, 6, 8, and 2, 4, 6, 8. So you draw overlap for your first carbon and hydrogen, and you draw your overlap for your other carbon and hydrogen, right? Okay. And then you draw your overlap for your hydrogens too. See? So this is your overlaps. You got 1, 2, 3 overlaps, right? Your central overlap, so you got 2, 4, 6. How many electrons take to make a single bond? 2, right? 2 electrons, right? So that's 1, 2, 3. See, triple bond. So now what I asked you in part number 3 is actually draw your bonds in, right? So this is number 2A, and then 3A. 3A, you just draw in your bonds. So you say hydrogen, there's 2 electrons there, draw a single bond. Then you see a carbon, you just read right across. Then you got, see, 2 electrons here, so I'm going to draw one bond. 2 more electrons there, I draw a double bond. 2 more electrons there, I draw my triple bond. Is everybody following this? You following? You cool? Okay. Sure we cool. 2 electrons here, single bond. There you go. There's your simplest case for alkyne, I believe. That is alkyne. All right. CH4. CH4, you can just do clockwise. So this is 2B. This is CH4. So you got 1, 2, 3, 4, right? Because it's group 4. Now I can draw my hydrogens in to bond with each of them. Right? Hydrogen comes in 1 electron each. Now I draw that encompass my overlap. See? 2, 4, 6, 8. Carbon's happy. Right? Now you get 1, 2, 3, 4. And then 2 part, this is 2 part A. And 2 part B, I really ask you the same question. I just say drawing your bonds and replace it for your overlaps, right? So hydrogen with 2 electrons here, single bond. Carbon, 2 electrons there, single bond. Carbon, hydrogen, 2 electrons there, another single bond. 2 electrons there, there you go. Easy, right? Easy exam, right? All day, every day. Outside, by yourself. Is that? All right, 3A. All right, 2C. Let's do 2C. 2 part C. This will be 3 part A. I'm confusing my numbers here. I think you get what I'm saying. Okay, 2 part C. C2H4. 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 So what you should see is that when adding the carbon to take the place of that, see, it necessarily creates a, what is that, a double bond? Is that? Yeah. So let's draw it out. So you get carbon has 4 electrons around it, so you want to choose smartly. So you say 1, 2, 3, 4, right? Do it again. 1, 2, 3, 4. See? And now you got a case for 4 hydrogens. 4 hydrogens come in there, right? You say 1, 2, 3, now you can draw your overlap, right? Overlap, see? 2, 4, 6, 8, that carbon's happy. 2, 4, 6, 8, that carbon's happy. Now some of you got confused with that because what happens is you count the total share on each one. Does that make sense? Some of you try to add in extra electrons and make it work. You're overthinking it, right? So you actually, it's okay to double count as long as you reference it to that same atom, right? In other words, see, 2, 4, 6, 8, that carbon's happy. I can double count when I go to here. 2, 4, 6, 8. So it's shared electrons, not extra going all over the place. Does that make sense? A little silence.
You're supposed to have 2 circles, one around each seed.
Yeah, that's
Except
true.
for one big one.
Yeah, that's true. You can do it like that. It will be.
You gotta eat all of it.
Yeah, you're right. It's your Venn diagram. There you go. Now, when you start doing your 3-dimensional diagrams, you start to overlap anyway, right? It's kind of crazy, but yeah, technically that's correct. You want to separate the two. All right, so then you got 3C. 3C, 2 electrons each. All right, double bond. All right, there you go. That's an alkene. See, this is alkyne, right? Single bond would be alkane. Alkane group. This would be alkene. Alkene. Now, see, alkyne triple bond, alkane single bond, alkene double bond. That gives you a whole classification of compounds or hydrocarbons or carbon-based molecules. So you should know those next time, right? Right.
You said this will be your compound? Say it one more time.
These are classes of carbon-based compounds, and they are classified according to their bonding. And so, what I've set you up for is to see these specific cases building up from the octet rule and the rules for developing and drawing out your bonds, making that connection. That's a very important connection to make. Because once you got that, these are your basic compounds that set you up for your different classifications for your carbon-based compounds. So you have, these are 3 basic ones. And the 3 basic ones because you have 3 types of bonding, right? Single, double, triple bond, right? See? So alkyne is a triple bond. So you have a whole bunch of classes of compounds that have triple bonds. You have a whole bunch of classes of compounds that have single bonds with carbon. See? Alkane, those are alkane groups. And you have whole classes that have double bonded with carbon. So that becomes important when you start doing organic chemistry. For those of you going on to organic chemistry, that's important to be able to distinguish between what's what. You see a double bond, alkene. It's all carbon-carbon. A carbon-carbon bond is a single bond, it's an alkane. Got a triple bond in there, it's an alkyne. Right? So if you heard of graphene, graphene is graphene because you have a pristine number of carbon-carbon bonds throughout the whole material. That's why it's called graphene. Right? You have graphidine or graphine, I think they call it graphidine, because you have triple bonds in an orderly pattern throughout the material. Right? And what's the other one? Graphene, same thing. I think it's called carbon. It's carbon. It's carbon. Yeah, I think Dr. What's his name? The building was named after him. He's the president of the school or something. But he found some molecule called, I think it was carbane, I think that's what it's called. In other words, He was the first one to isolate this one. I think it's called carbon, I think. And he's just carbon bonds. He's fooling around in the laboratory and found that one. Nobody really cared, you know what I'm saying? But then he probably made a big deal about it. And just kept riding that one discovery until he became president. It was cool. See what I'm saying? That's the way politics works. See, I'm not good at politics, so, but that's what you do. You find one little thing and then you walk around. Get some wine, you know. Get a couple of ladies. Oh, he should be president. And he's the president. That's the way the game. That's a great game played, ain't it? Am I lying? I ain't lying. You'll find out. Corporations work like that too, right? Corporations work like that too. Let's see. So yeah, that's that. I'm way off message. What was his name? No, it was a Broadnax. I'll remember in a second. Yeah. When I saw it, I was like, I said, why do you keep going? Why do you find something else, huh? You know why? You probably found it by accident. One time. See? But he stopped, right? He stopped. See how they do? What's this? Dog corresponding compounds. All right, so we already did that. Label the hybridization order, right? I was really surprised. Most of you got that one pretty good, right? See? So this is SP2.
I think I should receive partial credit for this.
SP3. And SP. And the key is just realizing that these bond orders are antisymmetric to the number of bonds present on the carbon-carbon.
Okay. So with the first one you said that's SP, but I thought you said that was a triple.
This one?
Yeah.
Right, exactly. See, so what happens is it's opposite, right? The bond order is opposite of hybridization. So in other words, you got single, double, and triple, right? And single bonds are pretty long. Double bonds are a little shorter. Triple bonds are even shorter, right? Now, the shorter the bond, the stronger the bond. So triple bonds are the strongest bonds in nature. Okay? Now, the hybridization order is antisymmetric to this. In other words, the single bonds can be sp3. The double bonds can be sp2. And the triple bonds can be sp. All right? And I actually got to go and refresh a little bit to make sure I can make sense out of it a little more as you move forward, when you look at your overlaps. So that'll be next class. We'll go a little deeper. What was it? Oh, so to have a, we'll talk a little bit about it now. So like for a single bond, how's the word? Yeah. For a single bond, all you need is 2 electrons, right? So that corresponds to a sigma. That's a sigma bond, right? Sigma bond. Okay. For a double bond, the criteria for a double bond is that you must have 1 sigma bond and 2 pi bonds. All right? So what is a pi bond? All right? So a pi bond is, let's say you have a carbon and a carbon here, right? And you have electrons available for bonding, so that's going to form a pi configuration here and a pi configuration here on each one, right? What happens is that above and below the plane, these two pi orbitals attract each other. See? And so you have, this is called a pi bond. It's called pi bond. Pi bond. So this is pi, this would be pi and pi star, which you can see. They tell you where orientation, which one you're talking about. So this is one pair of pi bonds, right? So one pair of pi bonds and then one sigma bond, see? One sigma bond. So you have one sigma bond and two pi bonds. That is the definition of a double bond. See? And we'll talk a little bit more about that next time, but that's, just keep that in mind. All right. Now, triple bond, I believe you gotta have, what is it? Two, yeah. Was it one sigma bond and two, four pi bonds, right? Yeah, 4 pi bonds. One sigma bond and 4 pi bonds. In other words, you'll have pi bonds above and below the plane, and then you also have some more pi bonds coming at you in and out of the board, right? Okay? So you got pi bond action going on here too. See, pi and then pi star. See, but so getting complicated like that. See, that's one sigma bond and 4 pi bonds, something like that. So 2 pi bonds. Actually, and we'll talk more next time because I gotta read up a little more. But this may be considered 1 pi bond and 1 sigma bond, and then 1 sigma bond and 2 pi bonds will be a triple bond, right? Because they come in pairs. Just think about that. So that's how you get your bond order. Now for the last one was the easiest one. Last one was the easiest one, right? We start out with the equation 1/2 mv squared equals energy, right? Kinetic energy, right? Solve for V, right? V equals what? 2 E over M. What's that? Square root, right? Technically, you have two solutions there, but we'll just go with one solution, keep it simple. Plus and minus, right? Take square root of something. Plus and minus, right? Two solutions. We'll just go with this, right? We'll just use the positive, non-negative solution. And then you want to write the angular momentum in terms of kinetic energy, right? So we gave you 2 L equals mvr, right? So all you have to do is substitute for V, right? L is equal to M square root of 2E over M times R. You're done. That's all you have to do. That's 2 steps. Y'all are doing all kinds of stuff, y'all. I did give you partial credit. I gave you partial credit. Yeah, dude. I gave you half credit. I gave you 8 out of 15. Look at the bottom. See? Didn't I? There you go. 8 out of 15. Look at it. Look at the bottom. 8. You see 8 down there?
For the last one.
That's what I'm talking about.
Ain't talking about that.
Yeah. I gave you half credit. With all that nonsense you wrote, I gave you half credit, huh? Didn't I? I gave half credit, didn't I?
Yep, sure did.
I mean, this one, look, see, this test was like very fair, right? 5 points per,
Number 3.
the A, B, C, D, each one, little one was 5 points, right?
3D.
3D?
Yeah.
Oh, no, you messed that one up. You messed that one up. You messed that one up. You gotta do better next time. This is a cool test, right? It was like real reasonable, right?
Yes.
Right? I didn't have anybody trying to strangle me or nothing, because I just made it too simple, right? It's everything we went over in class, right?
Yes.
Word for word, wasn't it? Yes, ma'am. Well, you got it. I know you for real. I know. You got it. I hear some Bobby Womack music playing in the background. Any more questions? It's midterm week, right? Okay, so, but you already took your midterm, didn't you?
Yes.
See how it rolls? You see what I'm saying? See that? Let me see here. Oh, okay. So what we're gonna do next, kind of make it overlap with your laboratories a little bit. We'll go over concentrations. We'll call it a day. How many have done concentration problems before?
Well,
Yeah.
no, I don't.
MV1 equals MV2. M1, V1 equals M2 times V2. You know what I'm talking about? Okay, yeah, we definitely, if this is General Chem 1, you definitely got to go over that. So,
We got that for
very briefly, I'm going to just give you some reading to do on that.
It's the turtle. Remember that video I told
It's 15, right? 30? 15, right? 50 plus 25. 30 plus 15, right? 30, 20, 50, right? 50 plus 25, what's 50 plus 25? Right? What's 50 plus 25? 50 plus 25 is
Sprint, this is not sprint, a marathon. That's how it's
30 plus 20 is 50.
went up the hills and
50
shit.
plus 25 is 75. Same 5 plus 8. Yeah, you had it. You had it. 30, 50 plus 25 is what?
Comes down.
75. 75 plus 8 is what? 80.
No.
Yeah, you had it. 30. 30. Right? 50. 50 plus 25 what? 75. Plus 20.
Make it to that class.
Yeah, there you go.
What do you say?
There you go.
You know Clayton County area? Yo,
Trying to add stuff.
Where was that?
huh?
Where was that?
Add stuff.
Like, it's hard to say. But it's like, you know Charles Moore High School, right?
Yeah. Is it off 138, 85?
No, it's on Terra Boulevard. Well, no, not Terra Boulevard. It's on Garden.
So right when you get off the interstate, go to Tower Boulevard.
No, I mean like, it's kind of hard to explain it because it's weird how you guys set up. So it's like Highway 75.
Yeah.
Yeah, it's on. Just go down there, and then like you should come across the Garden Boulevard.
Guard Walker.
Huh?
I know what Guard Walker is. So you said Coastal Jonesboro.
Yeah, kind-ish.
I live on 138.
I know. That's why I'm
My
talking
car today. Actually, I got the right part. Well, I got the part. So I took the whole thing out, man. I'm talking about I ripped the whole engine apart. Not the engine itself.
Yep.
The front.
Look at the face.
That was the
All right, so what you should read over for Thursday. I'm not gonna sign the official home, but read over this, right? You should see, look at any problems that have to do with, say, for example, start with certain problems. M1 V1 equals M2 V2, right? They're concentration problems. Like you can't do chemistry, like actual, like real chemistry when you're on the wet bench. It's impossible to do chemistry without this concept. Yeah, look it up for me.
What is it?
Concentrations. Concentrations.
We doing this.
You hate me when you pass me. That's it.
Yeah. No, that won't. That was
All right. So this would be like, for example, you may be given like molarity. What's molarity? Yeah, what are units for molarity?
How many?
What are units for molarity?
Do it, start with it.
You don't know units for molarity? Should be grams per liter, right?
Oh, that's right.
Right? So molarity is going to be grams per liter, and V is your liters, right? It's volume, right? So you'll be given like, you might say, how many grams of calcium chloride, for example. Do I need for a 6 molar solution of something with hydrochloric acid? It might be something like that. I'll let you look up those kind of problems, right? And basically, in general, what it is the key to this is you got to understand your dimensional analysis, right? So the thing is that you be given a certain, you may be given a molarity in the beginning, and you may have to find out like how many liters you have to add of a certain solution to get your final result. See, and you play with this. So but this is your general equation right here. Use your concentration, yeah. Yeah.
Are you teaching Chem 1 or Chem 2?
What are you talking about?
Like, what?
This is
concentration is like way somewhere over in Chem 2 section.
yeah. This is gonna.
Why are we in Chem 2?
Yeah, you'll encounter this in Survey of Chem 1, Survey of Chem 2, Chem 1, Chem 2, Organic Chemistry 1, Organic Chemistry 2. This is like fundamental throughout. Okay?
So what chapter is
Yeah.
Can you talk about the throughout chapter?
Well, let me see the book.
Here, it's on the video.
That's y'all. Oh, it's Gatorade. Shoot. You may see it on these solutions, you may see it on these concentrations.
511 to 514.
Yeah, here you go. See, that's right there, right there. Here you go.
144, 145.
Yeah, chapter 4.
Okay, check it.
That ain't no Chem 2. Yeah,
When you say that, no, I don't see it.
you all the way in, chapter 32. No.
Okay, I'm looking at chapter 4, but I don't see it.
So go to look at chapter 4, types of chemical reactions and solutions to a
Composition.
4.4?
Yeah.
4.3, 4.4?
4.3, I think, composition and solutions.
Yeah. So yeah, 4.3 composition. So read through that and do a couple of sample problems. Okay. Because it's almost impossible to do chemistry without this. I've actually tried it. Trust me, I tried it.
Okay, so you said 4.3, 145, and what else?
Yeah. So for example, it says what volume of 16, this is this is on page 151. What volume of 16 molarity sulfuric acid must be used to prepare 1.5 liters of 10 molarity hydrosulfuric acid solution, right? Okay. So they're asking for B2. Asking for volume 2. But they give you the molarity. So yeah, you do stuff like that. You see here at the bottom. You see at the bottom, right? Page 151. You see the equation I'm talking about.
Our papers are different. Anybody have a video paper?
Yeah, title is composition. Composition of solution. And questions, you're free to go, so, yeah.